Okay, 861. New formula coming. And this is the instance where you're going to have to use this new formula, because the cylinder and washer will not work for you. So let's say we've got this parabola. And we want to take the area from 0 to, let's chop it off right here. Let's say 6. So I'm going to put a vertical line in here. So I want to take this shaded region here and revolve around the y-axis. Well, so you know so far that we would draw our rectangles perpendicular to the axis. And the rectangle is not a problem here. It's not a problem here until we get up here. Up here, when we go to find our R1 and R2, they're both determined by the function. So the R1 is the function, the R2 is the function, and we'll be subtracting, and you get a 0 there. So you can't have your rectangle, both ends of your rectangle, touch the same function. So, rule of thumb, rectangle can't make the function touch itself on each end. So, what we have to do is turn our rectangles the other way, so parallel to our axis. So I'll redraw because we are going to do this one. Oh no, we're not doing this one. Everything's just in terms of. So we're going to take this back, stop it right about there. So now our rectangles are now parallel to the axis we're going around, because I'm going around the y. And when you see this rectangle rotate around, if you have vision, you're going to see like an open can, like an open cylinder. So as this goes around, I'm going to draw it down here. You will get a cylinder, open cylinder with some thickness to it. These are called cylindrical shells. So you can see it's like a thick can with an opening. These are called cylindrical shells, which we're just going to call shells. So if you think about this cylindrical shell, think of it as like a thick piece of paper coiled up. Remember when we open that back up? So if I was to slice this open, I am going to have a rectangle with some thickness to it. So when that coils up, it makes this shape here. So you'd have a bunch of cylindrical shells filling this region up. All right, so our goal is to get the volume of this, and it is a prism, and it's always a rectangular prism. And to find the volume, it's length times width times height. But let's think about what length, width, and height are in terms of the rectangle and the function. So first of all, this length is when it curls up, that is the circumference of the cylinder. And if you remember how to get circumference of any circle, it's pi d, but we're going to put it in terms of radius, so it's going to be 2 pi r. So the length, what we're going to use is 2 pi r for the length. The width is our thickness. That's either going to be dx or dy, depending on which way our rectangle goes. And our height is determined by the function. So volume is length times width times height. So for calculus, we'll be doing the integral from A to B for our shaded region. Our length is the circumference of the circle, 2 pi r. I'm going to put the h first because the h is, oh no, I'm just going to go like this, 2 pi r h w. And we're going to talk about what the radius, what the height, and what the width are. I already talked about the width. The radius of our cylinder is, let's go, the radius, because it's the distance over to each rectangle as it moves through our region. If I am moving this way, so if the rectangles are vertical, this is an x value. It's an x distance over. So the radius in this case is going to be x. If my rectangles are the other way, it's going to be a y value. So the radius will either be x or y. And I'll point that out when we go through the examples, depending on which way the rectangle is. The height is the function, top minus bottom, or left minus right, if we have more than one function going on. So height is top minus bottom, or left minus, or right minus left. And then your W will either be dx or dy. So for shells, your rectangle is parallel to your axis. With the cylinder and washer, the rectangle was perpendicular to our axis we were rotating around. Axis of revolution. So that's how you're going to tell the difference. If your rectangle is parallel, you're going to do the shell formula, 2 pi r h w. If it's perpendicular, it's either washer or cylinder. So let's do one so you can get the hang of this. We're actually going to be doing 2 of them. So number 1, we are going to take the region bounded by y equals 2x minus x squared and the x-axis. And we're going to rotate about the y-axis. So the graph is crucial, and then your rectangle is crucial to tell you what formula you're following. So 2x minus x squared, clear, 2x minus x squared. Okay, just a little parabola, and we're looking between that and the x-axis. It's the only region that's enclosed or bounded in or fenced in. So I'm going to exaggerate the size of this. Okay, and I want to go around the y-axis. Well, if you think about it, can I draw my rectangles perpendicular to the y-axis? If I try to do that, I make the rectangle touch itself on each end of I make the function touch itself on each end of the rectangle. So I am not allowed to put in a perpendicular rectangle. So I have to put in a vertical rectangle. And now my rectangle is parallel. So that's telling me shell formula. And what letters I want to see, because of my short distance being on the x-axis, that's a dx. So I want to see x's everywhere in my equation. So I want x boundaries. And then x is in the equation. So this is the origin, and then the other 0. I'm going to do it algebraically. So I will set 0 I know the y is 0. 2x minus x squared. I'm going to basket factor out an x. That'll give me x. 2 minus x. This is where my x equals 0. I already got that one. 2 minus x equals, 2 minus x equals 0. X is going to equal 2. So, shell formula. Volume will equal antiderivative from 0 to 2. Shell formula is 2 pi RHW. So, I'm going to write that in here again, 2 pi RHW. I'm going to identify the R, the H, and the W off to the side, then come back and fill it in. So I told you before, the radius is either going to be X or Y. Remember, the radius is the distance from the axis we're going around over to this. So that's a horizontal distance. That's an X. X values move left and right. Y values move up and down. So my radius is X. My height is top minus bottom. Top is the function. Bottom is 0. So it's just the function. And my width is dx. So plugging all three of those in here. Up 2 pi x. Height is 2x minus x squared dx. Okay, getting this ready to integrate, I'm going to distribute my x in. That'll be 2x squared minus x cubed. And now I can do my power rule on each of these and carry along the 2 pi. So 2 pi carries along. Adding 1, timesing by 1/3. And then that will be 1/4 x to the 4th. And we're going to plug in 2 and then 0. I can see the 0 is going to 0 out. So I just need to know what it equals when there's a 2 in there. So 2 pi, 2/3 x cubed minus, I'll go 0.25 x to the 4th and look at 2. Table, I'm getting 8.38. And then minus 0. And there it is. So, kind of nice that there's not any squares in there. Practice another one. See if you can get the rectangle the right way in the region and go from there. So number 2, we're going to take the region under y equals x to the 2/3 from x equals 0 to x equals 8. And we are going to rotate around the x-axis. Okay. Graph is crucial. All right, clear. Just x to the 2/3. Okay. And I only care about from 0 to 8, so I'm just going to put this branch in. And we're going 0 to 8. So we'll stop it at 8. Okay. I could absolutely do this with a perpendicular rectangle and do cylinders, but I want to practice the shell formula. So this one can be done two ways, and I'm going to do it the shell way. So shell means I'm going to draw my rectangle parallel to my axis. So I am going to put it in this way. And you can see all the way through this region, it's consistent on each end. It's the vertical line and then the function, vertical line and the function. So we're going to go with the shell formula. And because I've got these sideways like this is a dy. So that tells me I want to see y's in my equation and I want y boundaries. So my lowest y value is the origin. My highest y value is right here. And what I know about it is that the x is 8. So I just need the corresponding y value. So I can put 8 in there and get y is whatever 8 to the 2/3 is. 8 raised to the 2/3 is 4. So the volume equals the integral from 0 to 4 of 2 pi r hw. Radius, remember, radius is the distance from your axis, which is the x-axis, to each rectangle. So you can see that's a vertical distance. I told you the radius would either be x or y. So because this distance is vertical, the radius is equal to y. The height of my cylindrical shell, or the height of my rectangle, because it's laying down, is going to be right minus left. So it's going to be 8 minus the function, but I need the function in terms of y. So I'm going to take this. And remember, all I've got to do is raise to the reciprocal power. So that'll be y to the 3/2. And my w is going to be dy. So radius is always either x or y. Height, top minus bottom, or right minus left. And width is dx or dy. Okay, substituting in. 0 to 4, 2 pi y, 8 minus y to the 3/2 dy. So same algebra as last time. We're going to distribute and then do our antiderivative rule. So we will have 8y minus y to the 5/2. So going here, carry along the 2 pi. 8y squared over 2, that'll be 4, minus y to the 7/2 times 2/7, evaluating from 0 to 4. I'm just going to make that a 4. And it's just a matter of plugging 4 in here because 0 is going to 0 out. And that will be it. Okay, I think you can trust me here. If I plug in and type everything in right, I'll get 172.34. All right. So, in summary, if your rectangles are perpendicular to the axis that you're rotating around, you have cylinder or washer. If your rectangles are parallel to the axis, you have your shell formula. Okay, so tomorrow, I won't even tell you what's coming. We'll leave it at that.